In this video, I want to review the midterm exam with you. I did this in lecture, but I'm going to record a video so that all of you can see this information. I shared my solutions together with my grading criteria on Brightspace, so please use these to study for the final exam because the structure will be very similar, right? And I guess my main goal with this video is not to just go through the questions and answers, but to tell you what I observed in the exam so that you can do a bit better later on. Yeah? Even better, actually, later on. So question one was about waterfall. A lot of you really described the idea of the waterfall being this linear process where one activity only happens after the previous one was completely done. And the idea was that, well, if you can do A before B and you do A in a good way, then you can do B and you have less risks when doing B, right? Because all the questions were already answered in the previous step. You also showed to me the phases. I was really looking for it to see if you know the phases of doing software, because they appear in the waterfall method, but those phases, they should happen in any software development process you have, right? I think my tip to you is, in some of the answers I saw only the diagram in there, so I could see that you know in a way the phases, but it was hard for me to judge whether you understood this ideal of being linear or whether you just memorized the picture. So this was just too succinct. I like short answers, but this type of answers are too short and then hard for me to judge if you know the concept behind that question. List and explain disadvantages of the waterfall process. I don't have a lot to say in here. I observed basically all the disadvantages we discussed not only in the slides but in the lecture as well. So I was pretty happy to see that even things that I didn't put explicitly on my slides were mentioned in the exam. A tip for this type of questions, where you have to list and explain two different things, make sure that there's a difference between the 2 or 3 items you're putting in there. In a very small number of examples, I had the impression that, 1 was very similar to 2, so it was hard to give full points on this one. So make sure it is clear, the difference between all your answers are clear. Then I had a question about Scrum. You also did a very good job in there. I saw lots of personal experiences in there. I suppose this comes from the project that you're doing. I see people explaining how they did planning in their projects, how the reviews and retrospectives went. In this question, I think the common or one of the mistakes I observed was some people switched the answers between review and retrospective. So they explained it retrospective in the review and the review in the retrospective. So small mistake, right? So pay attention for the next time. Regarding requirements engineering, this one we observed lots of different answers. I think one common mistake I observed in there was that some people said that functional requirements are important features, whereas non-functional requirements are the less important features. So this is not correct. The importance of the features are not really related to whether they are functional or non-functional requirements, right? You have lots of non-functional requirements that are really important. Think of a payment company. If the payment takes more than 10 seconds, well, the company cannot work. So this is an example of a non-functional requirement that I can see being very important, highly prioritized in the backlog. So the main separation in here, and I just recorded a video on requirements engineering just for this, is that the functional requirements are more related to the business side of your software, right? What kind of features does your software do? So think of inputs and outputs and concrete features that implement the business rules of that software. The example of Brightspace, right? A functional requirement would be for students to deliver assignments, for teachers to provide grades, so on and so forth. And non-functional requirements are more related to the constraints that your software has. And those constraints can be, for example, performance, security, storage. So they're not really related to the business itself. We're not talking about how teachers uh, provide grades or how students submit assignments, but this is more like constraints that we need to implement in there. For example, one constraint in a Brightspace system can be we need to support groups of 2,000 students. Um, yeah, this is a non-functional requirement. Then characteristics of a good requirement, I observed lots of different answers. I was very surprised to see that although I focused a lot on UML in the exam, I also saw uh, ideas of good requirements from the agile user stories part of my lecture. So I have nothing to say in here. The difference between agile requirements and UML requirements, um, I think the common mistakes in there uh, um, were that people were saying that UML requirements don't ever change, whereas an agile requirement is more adaptable. I think this is, although correct, not the best answer to this question. And let me rephrase it. I don't even think this is correct because UML documents are not really fixed or not adaptable, so to say. There's adaptation in UML as well. It depends on how you do your process, right? A requirement needs to evolve. We discussed this in the requirements engineering lecture. I guess the difference between an agile and an UML requirement, what I wanted from this question is that in an agile requirement, they are naturally shorter, but because they complement this shortness with people, with communication. So your PO is present, your stakeholder is present, and you can ask the person, what should I do in this case, right? Whereas in the UML, although you can of course have your POs and everybody closer to you, when we're doing UML, we're a bit more strict, right? So we really try to be a little bit more complete on the requirement beforehand. But it does not mean it doesn't change, right? In practice, because you're having some sort of agile methodology in there, you can always ask questions about your requirement. It can evolve. So that I think this point of UML not evolving actually is what industry thinks in a way, and this basically means, and maybe this is why people don't like UML because they have this misconception in their heads. Then when it comes to the UML use case diagram, I saw lots of beautiful diagrams, very well done. I think 99% of the answers had all the actors, all the functionalities. Common things that I can talk about. So in some use cases, I saw that these two use cases were connected. See doctor's agenda and book a slot as if they were one thing. And while it's always tricky to discuss whether they should be combined or not, I think seeing doctor's agenda and booking a slot must, it's a complex feature by itself, and it deserves its own use case. I see people putting this as some relationships in here, like includes and extends, and we accepted those mostly because it really depends on how to see the features being implemented, right? We also see depend relationship. Most of you notice that you can only do the rest if you register in the portal. So we could see some depends relationship in there. So overall, we were quite happy with how you did this use case diagram. You did very well. We only discounted a few points when we saw a relationship that we really couldn't see in any universe. We couldn't make sense of that relationship. Yeah. So my suggestion for you is if you see some sort of relationship, try to explain why that relationship is there. Yeah. Maybe I'll put this as a compulsory thing for the next exam. So make sure you can explain to me why your relationship is there. Then the state machine, you also did an amazing job. Most state machines were very, very good. What we observed is questions I got also during the review lecture. In here we have two edges coming back to the on state, so time is reached and cancel. Yeah, you can do this with one edge only, that's okay. Then you write time is reached or cancel. I'm totally fine with that. I think the two mistakes we observed and something to improve is, so first make sure you have an initial state and an end state, right? You gotta have those. It's very common to have those. But I think the most important mistake we observed is we saw some people putting decision blocks in here. So the diamonds you can use in activity diagrams, we observed in a few state diagrams, and it makes no sense at all, right? That there's no decision. So the decisions are represented by transitions, right? You are in one state, something happens in your system, which is a transition, which takes you to the next step, to the next state. So if you had a decision blocking there, this means you have a misconception on the state diagram. So make sure this doesn't happen in the next exam. What else? In some exams, I saw the turning off state. So from on, turns off happens, and then there's a turning off and then off. It does not make a lot of sense to me, right? So turning off is not a state. There's a verb in there, turning off, right? So it's clear that this is a transition. A state would be off, right? Then the activity diagram was also very well done. A lot of them very, very similar to my diagram over here. You were able to start a parallel activities, and you were able to synchronize them. Very good. What happened in here? So we saw a few examples where they didn't really look activity diagrams, right? So there were no rounded squares, there was no synchronization bar, more like an arrow and then 3 arrows. And although I could understand that you understood the process of modeling an activity, we also want an activity diagram over there, right? So make sure that you don't have to have artistical skills, of course, but make sure you do something that resembles an activity diagram. We also saw some people using the normal rounded squares to generate inputs and outputs. That was very nice. We even gave you bonus points because this didn't happen so often. So, but make sure when you create an output, this output really means something, right? For example, in this exercise, I think it would be nice to have a rounded box here that, it is the output of this one, issue product warranties. Probably for a system like this, a warranty is something that is really created, right? It's a piece of paper with an unique ID that you can send to your user. So it's an important concept abstraction for your business. I would represent it. I saw some people creating an email. Yeah, an email seems to me something so common. Unless it's a very important concept to your project, I wouldn't represent an email, right? So this is a trade-off you have to do. You have to highlight important information, and what is less relevant, you avoid putting them on the document, because otherwise it's just more things for people to read. Then we went to the testing question, and about input and output partitioning. We had this problem over here, the count function that comes directly from the Python documentation, and we asked you to do some partition testing in there. And this question was particularly tricky because there are many partitions you can think of. A few of you were able to find them all, and we were so happy. But the grading here was basically based on the number of correct partitions you found. I think what we observed was that a lot of repeated partitions, so 2 partitions that were basically the same, and therefore this means you divided the space in a wrong, you partitioned the space in a wrong way, right? A partition should be quite unique, right? It makes no sense to have 2 partitions and they exercise the source code in the same way. You're just spending money with it. Usually, how good you did this one was related to how good you could do B. And we saw very good outputs in here, yeah? Then we went for the control flow graph. This question most of you also rocked. Lots of very good questions, very good answers. I'm trying to remember problems in the control flow graphs, but I cannot recall one. So usually you were able to represent control flow graphs in a very decent way. And then usually, of course, how good you did this one was related to how good you were able to do this one. From this picture, you can easily see that we need to have at least 3 test cases if we want to cover all the branches, right? At least 3, because the way this implementation is designed, that's what happens, right? So if you explore this, you have 3 tests. So if you came up with 3 perfect tests, we gave you full points. Something that we observed was people in here, instead of putting 10, 10, 10, they put x, 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 and then in T2, x, x, y. So they created a test in a generic way. So make sure when we tell you to devise the test suite, we are looking for the concrete test case, because you already had some abstract partitions before. So this one is a concrete test cases, so concrete values that would exercise the software in the way you want it to be exercised. We also saw some tests with triangles that are 0, 0, 0, 0, 0, 1, and this is tricky because in a way this source code would accept those things, but a 0, 0, 0, x, y, and z is not a triangle, right? A decent implementation of a triangle problem would return false. This is not a triangle. And then if in here, if you tell me that your oracle is like 10, 10, 10 should return equilateral, this is quite wrong, right? A 10, 10, 10 is not equilateral. This is an invalid, 0, 0, 0 is not equilateral. It's an invalid triangle. We didn't discount points on this, but make sure that your test cases, they do make sense, right? And that's how you actually find bugs. So you basically, you found a bug in my implementation. 0, 0, 0 returns equilateral, and it should return error. Explain the oracle problem. I think this was tricky. Just a few people got it right, actually. And the idea of the oracle problem is, given an input to the system returns something. How do I know that this something is the correct output for that given input? So this is the oracle problem. We need something that tells me that, well, given this input, this is the correct output. And the way we have been doing in this course is that the human is the one providing the oracle, right? You, when you write the tests, you provide the oracle. Given this input, given the 10, 10, 10 for the triangle, the output is equilateral. But you can see that this is a big problem in software testing, right? If you're just trying out different inputs and then, in a systematic way, so you write a program that just tries random things in there and you get lots of outputs, that's very cool, because you can write a program that just tries to give you inputs, and this will create thousands of test cases faster than you could. But then how do you check whether the output is correct? So this is what this oracle problem is about. And finally, the Git representation. A lot of you had a picture very similar to this one. I even thought, did they have access to a computer in there? Because the picture is very similar to the one from Git visualization website, so you understood my tip from the lecture before the exam. I liked that. I think the most common mistakes I observed, so first was when I do git checkout in here, I'm just moving between branches, right? It doesn't create a commit. So in some of the answers I saw like a circle in here, as if B1 was a commit, and as if master was a commit whenever I changed branches. No, so the git checkout instruction mostly moves you from one branch to the other. And the direction of the arrows, so the arrows should always point to the parent commit, right? To the commit before the current commit and not the other way around. But overall, you did very well in these questions. So very good. For the final exam, you should expect a similar type of questions where you have a theoretical question, you have to explain to me a technique or explain to me advantages and disadvantages of some software engineering decision, as well as lots of questions for you to apply the techniques we discussed, like the questions about creating control flow graphs, activity diagrams, etc. You can definitely expect, for example, for the control flow graph question, if there is one, the source code will be a bit more complicated than this one, right? Or the same for the state machines. This state machine in particular was quite similar to the one I discussed in the lecture. So if you followed my lectures, you were able to devise this one, but now you might expect a problem that is completely different from an on and off microwave. Yeah. For the open questions, make sure you can convince me you know about that topic. So this should be your goal, right? Convince me that the underlying knowledge I'm trying to look, do you know Scrum? Do you know Waterfall in the case of this exam? That you really understood these concepts, right? So that should be your goal, to convince me you know about the topic, and I can be sure that if I give you 1 in the question about Scrum, this means that this person understood Scrum 100%. Yeah? Folks, that's it. I hope this video helps you to prepare for the final exam. Bye.